Hello everyone, welcome back to Edexcel Science channel, and now we are at the last question, which is question number 4 from 2026 June IAL Physics Unit 3 paper from Edexcel. A student investigated the motion of a toy parachute as it fell through the air. She attached a mass to the parachute as shown. The student dropped the parachute from a fixed height and determined the terminal velocity v. Describe a method to determine a value of v. You should include any measurements needed and how the student should ensure that the parachute has reached terminal velocity. So what they're basically asking us is the student is going to drop this parachute from a certain height, and we need to calculate its terminal velocity, and we also need to ensure whether the parachute has reached terminal velocity or not. Now, guys, what is terminal velocity? Terminal velocity is the constant velocity reached by an object in motion when all the resultant force on it adds up to zero. So there is no resultant force, so acceleration becomes zero, so velocity becomes constant, right? Now, the setup that the student should use is something like this. So let's assume that this is the parachute, okay? Uh, okay. So let's say that this is the height that the student is going to drop the parachute from, okay? Yeah. We need to measure this height, right? Because um, velocity is basically distance over time. So we need two values, which is the distance and the time. So to find out this distance, we can use a meter rule or we can use a tape measure. Uh, both are fine. Now to find out the time, what I want to do is I want to set up light gates. Okay. But I want to set up the light gates actually towards the end. The reason being is that we can be sure that the terminal velocity will not be reached in the beginning of the journey. Terminal velocity is usually reached after like the journey has gone for few seconds or few minutes, right? So basically towards the end of the journey. So I want to give light gates towards the end. Those light gates is going to measure the time taken, right? Now I want to find out the velocity at each of these points. If the velocity is constant, then I can say that the terminal velocity has been reached. Okay, so let's now write all this information down. So my first point is that measure distance using meter rule and time with light gates. You can also write a stopwatch to measure time, but light gates are way better because they don't have human reaction time and they don't have random errors, so they're much better. To find out the velocity, I'm going to use distance over time, and um, so we basically have to find out time for at least three sets of point. Okay, let's say this is point 1, 2, and 3. So um, find time or measure time, actually, that's better. Measure time for three different points using light gauge. Okay. And our final point, which is how to ensure. So I'm going to write that if the velocities are equal, then the parachute has reached terminal velocity. Okay, so that is the answer for question number A. And I also hope that you guys have understood the setup as well. Moving on to question number B. The relationship between mass and terminal velocity v is given by this equation. And this equation is not in our syllabus, and this is very common in physics. So where c is a constant that does not have any units, phi is the it's not phi, sorry, this is rho. Yeah, rho is the density of air, and capital A is the cross-sectional area of the parachute. Explain how a graph of m against a velocity square can be used to determine c. So whenever they actually ask you how a graph can help you or plot a graph, they're always talking about a straight line. Because in our entire physics syllabus, we do not have any graph that is going to be a curve. Okay. They're never going to ask you to plot a curve or how can you use a graph, which is a curve, to measure something. Okay. It's always going to be a straight line. So whenever you are faced with this type of question with an equation, your target should be to rearrange the y and the x-axis and the gradient and show how to find out the value that they are asking you to find. So let me rearrange this. So this is going to be my y-axis and this is going to be my x-axis. Whichever variable comes first becomes the y-axis, and whichever variable comes later becomes the x-axis. So m is equals c rho a divided by 2g multiply with my x-axis, which is similar to the equation of a straight line, right? This is our gradient. So I can say that the gradient is c rho a divided by 2g. And if we want to find out the value of c, then we have to rearrange it. So it becomes gradient times 2g divided by rho times the cross-sectional area. And that is how we find out the value of c if we plot a graph of m against v square. Question number 2. The student recorded corresponding values of m and v as shown. So now we are basically going to do this part in graph. Okay. So complete the table with the corresponding values of v square. So v square, and you also have to write the unit, guys. So unit is going to be m square and s to the power minus 2, which is basically, meter per second whole square, right? You can also write that, I believe. So this is going to be 50, 109, 19, 190, 266, 310, and 372. I believe that all these values have some sort of decimals, but since the values are large, I do not have to take the decimals into consideration. Okay. Now we have to plot a graph of m on the y-axis and v square on the x-axis. So let's do it. Let's do it together, guys. Now, while doing a graph like this in physics unit 3, you need to keep few things in mind, which is that the first thing you need to do is name your axis, which is a must, guys. If you do not name your axis, you will lose 1 marks. So my x-axis is velocity square, and you have to write the units, okay? So s to the power minus 2. And this is going to be my mass, which is in kilograms. Okay. So when you are done with writing the units, sorry, the quantities and the units, then you have to do the scaling. Now, when you do the scaling, you have to make sure that your scaling is sensible. In the marking scheme, this is a keyword. They will say sensible scales. Um, if you want, you can fit this entire graph in even one square or in just this space. But these are not sensible. If you can fit this whole graph, it would not be readable, right? So you need to use at least 50% of your entire grid, okay? That is the bare minimum. If you use 100% of it, that is even better. Then your graph will be more readable and your scale is much more sensible. Now, let's start with the x-axis because those are much easier, I believe. So I'm going to start from 0 and then my minimum value is 50 and my maximum value is 372. So I need a range from 0 to 400 basically on my x-axis. So let's try to fit that in my x-axis. So I'll take 4, 4, 4, and 4. Ah, fine. So I am taking 4 small squares as 100. So this is going to be 200, 300, and this is 400. Okay, perfect. Now, on my y-axis, my minimum value is 0.23 and my maximum value is 1.74. So I need a range of 0 to 2, basically, right? So what I want to do is, I will take 2 squares as 0.2. Basically, each square is 0.1, okay? So this is 0.4, 0.6, 0.8, 1, 1.2, 1.4, 1.6, 1.8, and this is 2. Now you see the space that I have used in this graph is basically this much, right? This is obviously more than 50% of the entire grid. So now all we have left with is plotting and then sketching the graph. So now let's plot, guys. 0.23 and 50. Usually I like to I like to read the y values first, okay? It's just much more helpful. So 0.23 must be somewhere over here, right? And the corresponding value is 50, which is basically over here. See, reading the y value is much easier. Like if you read the y value in the beginning and then the x and then the corresponding x value, then it's better. You can also do the other way around. You can read the x value first and then move up to find the y value, whatever you are comfortable with. Next, 0.55. So if this is 0.5, then 55 must be in the middle, right? Over here. Actually, let me use a different color so that it's easier for you guys. Okay. So if this is 0.5, then 0.55 must be in the middle. And the corresponding value is 119. So 119 is going to be where? So 100, 110, and then 20. Okay. So this is 100, 110, 20. So basically somewhere over here. All right. Then we have 0.9 and 190. So 0.9 is here and 190 is basically this one, right? 1.24, which is here and 266. So 266, if this is 250, then two more squares will make it 260. So somewhere over here. And make sure that your points are visible like this. Don't just put one dot because they might not be able to see it when they scan your copy. So it might cause you some trouble. 144. So 144 must be here. And actually, at this point is going to be one. Yeah, if this is 250, 260, and then yeah, somewhere over here. Yeah, sorry, that the last spotting was a little bit off, like by just one square. Yeah. So 1444 is over here, and then 310, which is here. Okay. Last one, guys. 1.74. So 74 is 2 square. So 372. 372. So 350 and then 60 and then 72. So yes, somewhere over here. Okay. So now we are done plotting our graph. But I'm not sure if my one is going to be accurate since I'm doing on a computer. But should be fine. Should be fine, guys. Okay. So now I'm going to draw my line of best fit, which seems good though. Oh my God. I thought that it will be all over the place, but it looks okay. It looks okay. So this is my line of best fit. So again, guys, what you have to do is you have to write the quantities, the units, a sensible scaling, clear plotting, and then your line of best fit. And that will give you, if you do all of those correct, then that will give you 5 out of 5. Now, question number 4. Determine the value of C using the graph. So in number 1, we found out that to find C, you need to use this formula, right? So what I'm going to do is I'm going to find out the gradient first. Okay. To find out the gradient, you need to take two sets of coordinates from either of this region. Do not take side by side, okay? Try to take 2 points from far end and always take points that cut cross and cross. For example, this is a very suitable point, okay? But do not take something like this one because it's not cutting cross, okay? And I am going to draw a triangle, which I'll come later. Yeah, this is a very suitable point. So what I want to do is I want to draw a triangle. This does carry 1 mark, guys. So you must draw the triangle even if you do not want to. Okay. Now I'm going to write down the coordinates of these points. So this one, so if this is 50, then this is going to be 25. And this is going to be 0.12. Okay. This one over here is 350. So this is 360. And my Y value is 1.68. Okay. I think basically the reason why they use the triangle is to find out the change in X and the change in Y. But I don't think anyone actually uses this triangle to do that because at the end we are just using Y2 minus Y1 by X2 minus X1. So that's that. But you have to draw the triangle. In the marking scheme, you see that they mention that use of a large triangle. So my gradient is going to be 1.68 minus 0.12 divided by 360 minus 25. And that is going to give you about, how much? Wait, 1.68 minus 0.12 divided by 360 minus 25. So that is going to give you 39 over 8375. Okay. I could have round up, but it's a very small value. So I do not want to round up right now. Now to find out C, I am going to use this formula. So gradient 39 over 8375 times 2g divided by 1.21 times 0.0704. And if you do this, I don't know if my one is entirely correct, but the method is correct, guys. It should give you something in the range of 1.06 to 1.10. And that is how you do question number 4. Okay. Moving on to question number C. The student repeated the experiment with a parachute with double the cross-sectional area. Explain the effect that doubling the cross-sectional area would have on the terminal velocity of the parachute. So if the initial size of the parachute was like this, what they're saying is now they're doubling the cross-sectional area of the parachute. So if your area increases, that means that the drag will be higher, right? So it will take less time for the drag to become equal to the weight. So let's draw a free body force diagram. So there is weight which is acting down and there is a drag. If your cross-sectional area is much more greater now, then the drag will be so high that it will take far less time to reach terminal velocity. Therefore, your velocity will decrease. So that is what I'm going to write. Drag would be greater and therefore it will take less time for um, drag to become equal to weight. So velocity will be lower. Okay. So that is it for this paper, guys. I hope that my explanation made things easier for you guys. Please don't forget to like and subscribe to the channel. It really, really motivates me to make more videos. If you have any suggested questions, if you have anything that you want to suggest, you can always comment in the post on the channel. And that is it for this video, guys. I'll see you in the next one.